So question 5 says, determine algebraically whether the given function is even, odd, or neither. So the function is 9x cubed. One of the things we can pick up on here is since the exponent is odd, this is going to be an odd function. So therefore we would say odd right off the bat. Now, if I want to verify this algebraically, we have two rules. F of x has to equal f of negative x. This is going to be even. In other words, we have what's called y-axis symmetry. So if I look at it from a y-axis symmetry, if you have this point, let's say this is 4 and this is, say, 5. So if 4 or 5 exists, what f of negative x means is negative 4, 5 must exist. So there's this symmetry across the y-axis. A lot of times, like parabolas will have this symmetry. These quadratics will have this symmetry. Now, an odd function, again, has what we call origin symmetry. So this has point symmetry. The origin is a point. So from an odd function perspective, if we have a point, say this, we'll call this 3 and this 2. So if there's a point 3, 2, for origin symmetry, this point's going to get mirrored across the origin. And you're going to have then this negative 3, negative 2. So negative 3, negative 2 would exist. So notice how the x and the y both have to change values for origin symmetry. So that's kind of what we're looking at, is y-axis symmetry and origin symmetry. Now, let me go ahead and clear this out of the way for myself. What they want us to do is do it algebraically. So for algebraically to happen, f of x has to equal this f of negative x. So we already have f of x equals 9x cubed. But to evaluate f of negative x means to substitute negative x in for x. So it becomes 9 times negative x cubed. Well, a negative raised to an odd power, that means there's an odd number of negatives, which means that's going to come out as a negative. So this is going to become a negative 9x cubed. So notice that 9x cubed does not equal a negative 9x cubed. So this is not an even function. It does not have y-axis symmetry. Now for origin symmetry, f of negative x, which we've already done, is negative 9x cubed, must equal the opposite of f of x. Well, the opposite of f of x means to take the opposite of the function. So that means this 9x cubed turns into a negative 9x cubed. So notice that f of negative x does equal the opposite of f of x, and therefore it does represent an odd function. So this would be odd. Now, if I want to graph it, y equals, and if I type in this function 9x cubed, 9x raised to the third power, if I graph this, this is what it looks like. Notice that for even functions, there has to be this y-axis symmetry. So if there's part of the graph over here, we should be seeing this graph being mirrored over here, and we don't. But also the origin symmetry, we do see this graph being mirrored across the origin. So if I look at the table, notice how there's this point 1, 9 here. Notice how there's also this point negative 1, negative 9. That's what we mean by origin symmetry. Notice that the sign of the x and the y are changed and represents the point that's mirrored across the origin. So we can also see it from a graphing perspective. So snake functions or cubic functions are going to have what we call this origin symmetry if they pass through the origin itself, that is. So number 5 is going to be considered odd. A quick way, like I said, is if you just look at the exponent, 3 is odd, therefore it is an odd function. Sometimes it's that easy.